type of SPD should you install when installing a subboard? And does distance really make any difference? It seems every week there's another debate about SPDs. Does it need its own MCB? Is type 2 enough? Do I need a type 3 as well? Do I need to fit one every 10 meters? And why is the term upstream and downstream still confusing? So in this video we're going to find out what an SPD actually does, what type 2 and type 3 actually mean, and what this 10-meter discussion is all about. But first, and this is as much for my benefit, what does upstream and downstream actually mean? To explain that, I've come to the River Trent. A river flows from its source to the sea. If we walk against the flow of water, we are moving upstream. If we walk with the flow towards the sea, we are moving downstream. Electrical current works in the same directional sense. It leaves the supply origin and flows towards the loads. So upstream means closer to the supply origin. Downstream means closer to the equipment using the electricity. If an SPD sits between the supply and an appliance, the SPD is upstream of that appliance. The appliance is downstream of the SPD. That directional relationship matters because an SPD can only control the voltage for what sits downstream of it. So let's remind ourselves what an SPD is and why it actually matters. Section 443 of BS 7671 deals with the protection of transient overvoltages. These are short duration spikes in voltage caused by switching events within the installation or atmospheric influences affecting the supply network. They are not overloads and they are not sustained fault currents. Modern installations contain a lot of electronic equipment. Control gear, drives, LED lightings and IT systems all rely on components that are sensitive to voltage spikes. An SPD is installed in parallel between the live conductors and earth. Under normal system voltage, it remains inactive. But when the voltage rises above its operational threshold, it changes impedance very rapidly and diverts that surge energy to earth. By doing that, it limits the voltage that appears across the installation. That limiting performance is referred to in regulation 534.4.4.2 as the voltage protection level, or UP. The voltage protection level must be coordinated with the impulse withstand voltage of the equipment being protected. The aim is just to not simply fit an SPD into the board. The aim is to ensure that the voltage seen at the equipment terminals remains within what the equipment can safely tolerate. In this case, we've been looking at these type 2 and type 3 devices from Schneider. Type 2 SPD is intended to discharge the main surge currents associated with indirect lightning effects and switching events. It is typically installed at the origin of the distribution board and is tested using the 8/20 microsecond waveform defined in BS EN 61643. A type 3 SPD has a lower discharge capability but provides a lower voltage protection level. In a combined type 2 and type 3 device, both stages are coordinated within one assembly. The type 2 section deals with the surge current. The type 3 section reduces the remaining voltage seen by equipment connected to that board. In a traditional staged installation, a type 2 device may be installed at the origin and a separate type 3 device fitted closer to individual items of equipment. Those separate type 3 devices rely on a degree of impedance between themselves and the upstream device in order to share surge energy correctly. If they are installed too close electrically to the origin without sufficient conductor length between them, coordination may not behave as intended. This is one of the reasons combined type 2 and type 3 devices exist. In a combined device such as Schneider's Acti9 units, the coordination between the type 2 and type 3 stages is engineered internally. The discharge capacity of the type 2 stage and the lower voltage protection level of the type 3 stage are matched within one assembly. This removes reliance on cable impedance between separate devices and simplifies designs in locations where multiple sensitive loads are installed close to the distribution board. So in a plant room where you might find a fire alarm panel, a solar inverter, PLCs, motor, drives and networking equipment all supplied from the same board, a combined type 2 and type 3 device can be an appropriate solution. Regulation 534.4.4.2 states that if the distance between the SPD and the equipment to be protected exceeds 10 meters, oscillations in the conductors can result in a voltage at the equipment terminals of up to twice the SPD's declared voltage protection level. Oscillations? Okay, so what does that mean? Well, to understand that, we need to understand what happens to the cables during a surge event. During a surge event, there is a rapid rise in voltage. Because of that rapid rise in voltage, there is a change in current, and that change in current is resisted, and that resistance is called inductance. And inductance can create additional voltages along the length of the cable. So the longer the cable, the higher the inductance, so the higher the potential voltage. Imagine striking one end of a long scaffold tube with a hammer. A shock wave travels along the tube and it is felt at the other end. And a surge behaves in a similar way. The SPD limits the voltage at its own terminals to its declared UP value. But a voltage wave travels along the conductor towards the equipment. If that conductor is long enough, the voltage at the far end can briefly be significantly higher than the voltage measured at the SPD itself. And it's this that the regulation is describing as oscillation. It's not the SPD failing, it is the cable becoming part of the surge circuit. And this is why that 10 metre figure exists. It marks the point where the effect becomes significant enough that additional coordinated protection closer to the load should be considered. So let's apply that to a typical small industrial unit. The supply enters at the main distribution board. At the origin we install a combined Type 2 and Type 3 SPD. The submain then runs 25 metres to a remote distribution board feeding control panels, drives and IT equipment. At the origin, the SPD may limit the voltage to 1.5 kilovolts, but the equipment at the remote board is connected via 25 metres of conductor. During a surge event, that conductor introduces additional voltage rise. The equipment at the far end may momentarily see a higher voltage than the UP declared at the origin. The SPD at the origin is doing its job, but the protective distance to the load means the voltage at the equipment terminals may no longer align with the intended protection level. If sensitive equipment is located in that remote board, an additional coordinated SPD installed in that board reduces the protective distance and maintains the voltage protection level at the point of use. So what type of SPD should you install when installing a subboard? If the equipment connected to that subboard is more than 10 metres from the upstream SPD and maintaining the declared voltage protection level at the load is important, then coordinated surge protection at that subboard should be considered in accordance with regulation 534. And does distance make a difference? Yes. Not because of a rule about boards, because cable lengths actually affect the voltage seen by equipment during surge events. So if you fitted an SPD at the origin and assumed that that is enough to protect the entire installation, well, it's probably not. And that's not because the device is faulty, but because surge protection is about system design, not just product selection. But what do you think? Have you seen these issues on site with SPDs and transient overvoltages? I would love to hear your stories, so let me know in the comments. And if you want to find out more about these Schneider SPDs, then check out the video Gary and Rick did, which should be on screen now.